Okay, so looking at this, we have the graphs of the functions f and g are shown above. The value of limit as x approaches 1 of f of g of x is what? So let's go ahead and trace along g. What is the limit as x approaches 1? It is definitely 2. So then what is the limit of f of x as we approach 2?
Oh.
And it is 3. It should be choice C.
I didn't get it until right now. I was not right. What?
Can you say that again?
So when you have a composite function like this, we can look at the inside first. Okay, so what is the limit as x approaches 1 of g of x? And we trace it along. And as we approach 1, either from the right-hand side or left-hand side, and it must match, otherwise it wouldn't exist. It must match, it is 2. So that is the same thing, so then therefore, we're finding the limit as x approaches 2 of f of x.
So aren't you finding the limit of x approaches 1 of f of 2?
Yeah. Wait, what? Yeah, I think you're saying.
G of x is 2, right? So it's the limit of x approaches 1 of f of 2, right?
Well, how does that?
I don't know. But I just don't understand why it changes to the limit of x approaches 2.
That might actually be the correct way to think about it, which would be 3.
I don't understand how.
So limit of x approaches 1 of g of x. But that's 2, so no. And then f of 2, yeah, f of 2 is 3. Yeah, you're right, f of 2 is 3. That's slightly different, but yeah, that's the correct way to think about it. Yeah, very good. Well, I admit when I'm wrong.
But I still admit it.
So let's look at the limit as x approaches 1. So you guys should have an understanding of composite, when it's not limits, you just, okay, this guy, and then whatever that is, then work from the inside out. So the limit as x approaches 1 of g of x is 2. So that value, so that is 2. So then what is f of 2? F of 2 is 3. Yes?
You're not writing down the
If you somehow found the equation of both of those, you can plug it in and then
Yeah, that's another way to approach it. But you should be comfortable with graphically, yes.
But
It was 3.
Yep, this is exactly it. F of 2 is 3. Yep.
so the limit kind of goes away, you just find f of 2?
Yeah, because the limit as x approaches 1, you say, okay, well, we have g of x, the limit as x approaches 1 of g of x is 2. And then, okay, f of 2 is 3.
So you just draft the whole.
So isn't it the limit of x approaches 1 of 3?
I feel like you only did like half of it.
Like, what about the limit graph?
I feel like maybe we just wrote this not how.
So it's kind of like working from the inside out. So the limit of x approaches 1 of g of x is 2, because we did that. As we approach 1, it is 2 from either side. And then f of 2 is 3.
Okay.
Yeah.
I wish it said.
So does it say why are you drafting the limit?
Because it's been taken care of. I don't know how to. I think we're making it. Maybe make it difficult.
No, I'm just confused with like why you just dropping.
Pretend like it says f of the limit of x approaches 1 of g of x.
No, I didn't do it.
I don't know why they did it, but that's like what they meant.
But whenever I ask you to go back, I find the inside of the limit inside, and then put that inside.
I didn't use that concept. Oh my god.
Okay, so now what we need to look at, guys, we need to look at the trig functions. derivatives of the trig functions.
Lord, here we go.
These are unfortunately something you have to memorize.
Wait, we don't get like a reference sheet?
This is your
This is yours. Yes.
I should probably check in with Dave.
She's not here. She's not here, no? Okay. That's okay. Thank you. Alright, so
So this is your reference sheet.
derivative of sine is of x is cosine x. Derivative of cosine x is equal to negative sine x.
We had a reference sheet last week.
So we need to memorize these for the test?
Yeah, unfortunately, yeah. The derivative of tangent x squared x. Derivative of secant x.
You mean sine squared x or secant squared x?
Secant squared x. Yeah. Derivative of secant x is equal to secant x tan x. Derivative of cotangent x is negative cosecant squared x. And the derivative of cosecant x is equal to negative cosecant cotangent. I wish they provided a reference sheet, but unfortunately, they don't. Do what you have to do.
You're right. What do you think about that? What's your tattoo mean? Oh, it's on my tree. So that's a trick function on this side.
I'm just like, how to
This one is integration right here, over here. This is kind of cool. I have a trick function. I'm gonna read that. I'm gonna read that.
You're like, what is that? Cover all body armor.
If you have a tattoo, you're not allowed to take this test.
They're gonna be like, you must wear.
No open toe shoes.
All skin must be covered.
You can only be showing 3 square inches of your skin.
Oh my god. My son sent me a while ago.
Alright, so you guys write this down.
In the cardboard box. Like,
So let's look at some examples here.
I can see your eyes and the mouth.
One on page 146.
Wait, what is it?
What page?
146. If you could read.
I wrote it for my health.
I got it. Thanks.
It says the directions are to find dy dx, find the instantaneous rate of change of y per instantaneous rate of change of x. Use your grapher to support your analysis if you are unsure of your answer. So we have y as a literal equation in terms of x. So we can go ahead, we can just go to the right. Okay, so dy dx would be equal to, when we're separated by addition, we just do each individual one. The derivative of 1 is 0. The derivative of x is 1. And then the derivative of negative cosine, the derivative of cosine is negative x. So the derivative of negative cosine would be, derivative of cosine is negative sine x. So the derivative of negative cosine x would just be positive sine x. So dy dx is equal to 1 plus the sine of x. And it says use your grapher to support your analysis if you are unsure of your answer. So you guys could use Desmos or a graphing calculator.
It's not hard. No. Yeah, I don't really remember how, but.
Again, the derivative of cosine is negative sine, so the derivative of negative cosine is positive sine. I mean, you could do product rule. If you want to see the whole thing worked out, you could do product rule, but you'll see that it's definitely sine of x. Okay, that's one example. Another example we have, we could look at number, say, let's go to number 3. 3 says y is equal to 1 over x plus 5 sine x. So we have a literal equation for y, so we can go ahead and just write dy dx. So the derivative of this, if you don't see it, what I think it makes it easier is just go ahead and we'll write it. Of course not.
It would be x to the negative 1.
Yes.
Oh, wait.
So y would be equal to x to the negative 1 plus 5 sine x. And so now, if we take the derivative of this, so dy dx would be equal to negative 1 in the front, drop it down 1, and then now the derivative of 5 sine x. Now, this is where we have to use product rule, which I'm going to have to assign you guys homework on these product rule and quotient rule because it takes practice. The derivative of the first is 0. Leave the second guy alone. Plus, leave the first guy alone, times the derivative of the second, which is cosine of x. Yeah, I like to do it in this. Now, of course, the order doesn't matter what you do it because of the commutative property of addition, but I suggest you do it this way because that way when you have to do the difference, when you have to do the quotient rule, you keep it consistent. You just go derivative of the first, leave the second guy alone, minus leave the first guy alone, or the second all over the bottom squared.
Wait, what's on? No, I need that one more time.
But I'll make sure we include a problem that involves quotient rule because it's more complicated. But for product rule,
We have to memorize that too?
for product rule, yes. For product rule, all you have to do is derivative of the first, leave this guy, leave the second one alone, plus derivative of leave the first guy alone, times the derivative of the second. So I rewrote this as x to the negative first. Because 1 over x is x to the negative first, yeah.
What happens if it's that way?
So I did it like this because we know that for the rule where we can bring the exponent to the front and then drop the exponent down a power. That's why I did that. Because it's easier for me to see. And then I can rewrite it. So then for this to be rewritten properly, dy dx would be equal to negative 1 over x squared. This guy goes away to nothing, plus 5 cosine of x. So there's a couple of problems. I'm going to show you a unique, not totally unique, but something that makes these interesting. So if I do the derivative of, actually, let's do it like this. If I say y equals the sine of x, y prime would equal the cosine x, what would the second derivative be? Negative sine x. And the third derivative? It would be negative cosine x. And the fourth derivative would be equal to positive sine x. We're going to repeat it back where we started. So the function y equals sine of x, its fourth derivative is the original function.
Can you explain why the derivative of negative sine x is negative sine?
Yes. The reason for it, if we work this out, so let's say we're at y double prime is equal to negative sine x. If I want to take the derivative of this, so I want to find the y triple prime, what I do is I'm technically doing product rule, because this is like, you can think of it like this to make it very clear. And I say, okay, the derivative of the first guy is nothing. Leave this guy alone. Plus, leave the first guy alone times the derivative of the second guy, which is cosine. So this would simplify, so y triple prime would simplify to negative cosine of x.
So when it's negative and it does, yeah, so when it's negative, we just do like that.
What's that?
When it's like a negative cosine, whatever, we use the cosine derivative.
Yeah, so you can always think of it like a negative in front of something as literally negative 1 times that value.
Do you know that everybody in this class has their phone number?
Well, I took a picture of mine because I took a picture of the thing.
In my hand, you're
You're gonna give me your referral
because you're not doing what I'm asking.
I'm doing everything here.
You really want a referral. You're going to put your phone in the drawer and you get at the end of the period.
This is just the derivative, so you have.
Yeah.
So yeah, so and then
Negative sine x stays with the same sign.
right, because you hear it.
Yeah. And then it goes back.
Yeah, is that true for every derivative or just sine? Like, just sine does that, or do any of the other ones?
Yeah, pretty much a sine and cosine. The other ones are pretty, they're pretty nasty written. If we look at the other guys, they get pretty nasty compared to, because then you have secant squared, and then you have to do the power rule to find the derivative of that, which would put you at here, and you do the product rule of that, and it gets nastier and nastier. So good question, yeah, they just get really nasty. These two are not too bad in terms of having to keep going down. One thing you can remember, maybe makes it quick, is like when it's of cosine, you put the negative, but when you do like of a sine, you just keep whatever it is. That helps like memorize it too. Can you may use the rest of your So that's that. So let's look at some more problems. I want to do one that involves quotient. So let's look at 7 is a good one. 7 is a good one. 7 says that y is equal to,
This is on the same page.
yes, page 146. Yep, y is equal to 4 over the cosine of x. And we're looking to find y prime.
Why can't you just take the cosine and put it on top?
So it's true that you could write this as y equals 4 times the cosine of, and don't think of this as arc cosine. This is why I hate the notation that some calculators use, and that's not what I'm writing here. Let's be careful. In fact, let's be a little, let's just do this. That makes it a little more clear. You could do this, and it's a good question. You know, why can't we just change to a product and just do product rule? You could, but what you're going to find out is you're going to have to, in order for it to look proper, rearrange all of it. So it's actually just if you're given a proper looking fraction, to just do a quotient rule.
But you can do
But
it.
yes, you can. Yeah, absolutely. Of course, you can change it to a product and do product rule. So if you really hate memorizing quotient rule, you can just memorize product rule. Yes.
Is that product rule, or couldn't you just do like the derivative of y, dy over dx is negative 4 cosine x negative 2?
No, you have to. This is definitely a product of 4 and cosine x to the negative 1 power. Yeah. So let's actually do it. Let's actually do it. So let me just do product rule, and we'll also do quotient rule. So let's do product rule. So y prime would be equal to the derivative of the first guy, which is nothing. Leave this guy alone, which is just what it is, cosine of x to the negative 1 power, not arc cosine, plus leave this guy alone, times the derivative of this. So the derivative of this, negative 1 in the front. Now you have to do the power rule, which means you have this come to the front, drop this down a power, negative 2, and then the derivative of the inside. I know, I'm not going anywhere. So bring this down to the front. Bring this down to the front, drop it down, and then the derivative of the inside. Derivative of cosine is negative sine x.
Wouldn't you just replace the cosine x with, so it would be 4 times negative 1, negative sine x to the negative 2 power?
No, this because now because we have to know understand the power rule, which we haven't done enough of, which I need to assign homework for you guys to practice.
In other words, let's just use the quotient rule.
Well, you also have to know power rule. That's going to be such a very common thing. You absolutely have to know it. So let's go over power rule right now. So the power rule, which we kind of brushed over it. So we go back to rules for differentiation, and this is the power rule for positive integers powers of x. It doesn't go into power rule for negative integer powers of x. Doesn't go into the details. So let's go over the power rule, which is going to be more detailed. That involves everything. So the power rule says
We're about to do quotient rule.
we'll do both. So power rule is saying if you have something, let's say d dx of say something to say u to the n. This is going to be, the general picture is going to be, you bring the n to the front, you drop this down one, and then it's the derivative of this d dx. Now u just represents any sort of function that's in terms of x, whether u is, and I'll show you some specific examples, where u is sine of x, or u is cosine of x, or u is something else like x squared minus 1.
What is the difference between this and every other derivative we've ever done? Like,
We haven't done a whole lot of derivatives. I mean, we've done very simple ones where if you have a monomial, you don't see it work out if it's a monomial because then the derivative of, let's say if it's just x to the third is 3x squared, and then times 1. You don't see the times 1. So I'll show you both. So let's go ahead and do both. Yes, you may. So let's do an example. And this is a good question you guys are asking. Like, why is this different? Because you're used to, let's say, if you had something like, I don't know, x squared, you would just say, okay, that's just 2x. But to do the whole thing out, it's like, okay, 2 to the front, drop this down 1, times, what is the derivative of x with respect to x? Well, that's just 1. That's why I don't ever write it, you don't ever see it when it's something that's simple. But that's technically what's going on. So let me show you an example of something that's a little more complicated that you have to deal with it. So if you do something like d dx, and probably this is why it does come up, because now you have to deal with ones that really you have to apply power, every detail of it. Let's say you have the cosine of x squared. What power rule tells us is 2 to the front, leave whatever the guts are, leave whatever this guy is alone for now, drop this down a power, times the derivative of the inside, which is negative sine x. I'll do another example.
It was like,
We did this last
It was
year.
like,
when we did it in a different way.
You do the derivative of, say,
yeah, it just was like 4 plus x squared.
x plus the x plus the sine of x to the 4th power.
Yeah, we've done that.
If you want to say, it says, we take the derivative with respect to x of this guy, So the power rule, or chain rule, right?
Yeah.
Okay, sorry, I got the 2. Hold on. I've done so many, I just call them, I don't even call them, I just do them, but sorry about that, so. But essentially, chain rule, as you're noticing, is the same thing. You just don't see it, you just call it, it's the same thing. So here, 4 to the front, x plus the sine of x, drop this down 1, then you have to do times the derivative of the inside, which would be 1 plus cosine of x. That's what, that is chain rule. This is chain rule. So let me outline what needs to definitely be outlined here, is that this is like the big picture of chain rule, this here. This will work for anything. And where u is just some function, doesn't have to be in terms of x, but if this is telling you, okay, now take the derivative of this with respect to x. So if it contains any x's, then you're going to see it work out. Right? U is just a very general way of our writing. So, okay, some other thing that's in terms of x.
So wait, so it's not.
So this can apply to anything.
Wait. Oh my God. You're multiplying it by today.
So when you have something to some power, what the derivative, you take the derivative, it says, just ignore what's in there for right now, ignore it. Take that exponent, bring it to the front, drop this guy down, then the derivative of the inside. That's chain rule.
Okay.
Yeah, I feel like you did that.
Okay, I have a question.
Yes.
I can't remember it, but I remember last year we learned a shortcut instead of like multiplying.
Like if
when
you were
you're
trying
trying
to simplify that.
Yes, and instead of like factoring it all out, like x beside this times x beside x, and like doing all of that, isn't there a shortcut for it?
To just simplify x plus sine x to the 4th power?
To the 3rd. If you were to simplify the
just solve
derivative.
that.
Oh, you mean expand it?
Yeah, but
Yeah,
isn't there a way to?
Yeah, you can use Pascal's triangle, but you wouldn't want to. There's no reason to for this force to be.
Oh, I could just like keep
You
it.
don't need to simplify.
Yeah, this is good. The inside
That sounds
With the
What's that?
That what do we do? Like, I don't remember how to do it. I remember you go on the triangle like this, and you go to the 3rd power, and you go down, and it's an answer.
Yeah, but I don't.
I
I did this last year. So I'm
like
like,
the 3rd one is that.
wow.
So let's go back to this problem where we were focusing on we were gonna do quotient rule, but then Lena says, well, can we make it a product rule? And the answer is yes, we can. So if we finish this, whoops. If we finish this, we would have y prime. Y prime is equal to, this goes away to nothing. Now this is going to simplify to where, okay, negative times a negative is the positive sign. So 4 sine of x, 4 sine of x all over cosine squared x, right? When it's a negative, you just bring it down the bottom and make it a positive.
Now, why when it's a negative exponent do we put it in parentheses and the exponent on the outside, and why now that it's positive we can write cosine?
It can be written either. It can be written either way.
Okay, then why switch it? What are you doing? Why?
Well, you should be comfortable with both. I'll say that.
Well, yeah, we always wrote it like that, the cosine squared of x. But before when you went and wrote cosine negative squared x.
Yep, they both mean the same thing.
Yeah, but you said something like.
Oh yeah, okay. So this, okay, what I was talking about with when it was like, what I was saying was this. When I had this, I was saying don't think of this. I'm not talking about arc cosine. Because on a calculator.
You don't even know what that is, so don't worry about it.
Okay.
Isn't it the inverse?
You should know. Yeah, inverse. Yeah, you should know what it is. But don't.
We don't know what that is.
Yeah. Yeah, that's what I was saying there, is that the notation is so confusing because typically when you see this, it is arc cosine, which is this inverse cosine. I'm saying, okay, I know that the cosine of an angle is this. How about what the angle is? Okay, well, you take the arc cosine of that value, and that would give you the angle. But what I'm saying is, the way it was written here, don't think of it as arc.
Yeah, that makes sense.
Which it is very confusing.
That's the notation right first.
You know, it's very confusing. The calculators that do say let that be arc, and it's confusing when you want to express no as just 1 over cosine of x. It is very confusing. Yes. So yeah, now let's try to keep the quotient rule. So if we apply quotient, which we should be comfortable with. So let's go ahead and do this guy as the quotient rule. So this was done by product rule.
I have a question.
This is done by product rule. Let's go ahead and knock out quotient
Can you
rule.
simplify that just a little bit more? The answer?
Nope, that's perfect.
That's perfect.
Yeah.
Because earlier you said, is that like actually cosine squared x or is it cosine x squared?
Well, it's
Like, is it all together squared or like?
so cosine squared x is the same thing as this.
Oh, okay, so that would be what we said, like, you just made that a tangent of bottom. Is that how it works?
Yeah, so sine of x over cosine of x is tangent of x.
Alright.
We don't have to do that. This is fine the way it is.
I'm like, it's here. I'm trying to be quieter.
So let's try to let's try to do it using quotient. Y equals 4 over cosine of x. Same problem. Same quotient. All right, here we go. So quotient rule says that y prime would be equal to, what I'm saying is the derivative of the first. Now I'm going to write it all out. Derivative of the first, leave the second guy alone, minus, leave the first guy alone, times the derivative with respect to x of the bottom, all over the bottom squared.
Can you say that?
So quotient rule is derivative of the top times leave the bottom alone, minus leave the top alone times the derivative of the bottom all over the bottom squared. So then if we continue, if we simplify this, the derivative of 4 is nothing. So this is nothing. So then we have negative 4. Actually, let me go ahead and just show it. Just so it's clear. The derivative of 4 is nothing. So we have 0 times the cosine of x minus 4, the derivative of cosine is negative sine, all over cosine squared x. And then if we continue this up here, then y prime would be equal to, that goes away to nothing. We have positive 4 sine of x all over cosine squared x. So we've got the same thing regardless of which way we did it. You do want to be comfortable with the quotient rule, especially when the quotients are more complicated than just a constant over a trig function, because the product will actually be a lot more work, and then you got to rearrange it. So you should be comfortable with both. So from today's lesson, I really want you to get the fact that you have to, unfortunately, you have to memorize the derivatives of the basic trig functions. But I think it would be a good idea to assign you some problems that deal with these rules, as we kind of, I think, brushed over maybe a little too quickly, because these do require practice. So we're going to do that. We're going to go back to chapter 3, and we're going to look at some homework for the rules for differentiation. So your homework is going to be on chapter 3.3, page 124.
All right. Got it.
And let's do horizontal tangents, dy dx. Where do we start to get into more just what that one? I really just want you guys to work on the basics. I really don't necessarily want word problems right now for this. I just want to work out some basic practice on why they're not providing. They have a lot of word problems here, but I don't want to do that.